Unit 7, Lesson 3B, Trends in Ionization Energy and Electronegativity. Recall that when we talk about reactivity, metals will decrease in reactivity as we go across the period, and they will increase as we go down a group. This is because the larger atom has a weaker pull on the nucleus, and therefore it is easier to lose electrons and become stable. Nonmetals, on the other hand, increases in reactivity as we go across a period. They will decrease in activity as we go down a group. The reason is the atom is smaller, and therefore there's a greater pull on the positive and much less or more attraction to the electrons. So with a larger atom, we got all this distance we have to cover between the charge of the negative and the positive, therefore it becomes weaker. With a smaller atom, the distance to cover is much smaller, therefore there's a greater attraction. When we talk about ionization energy, we're talking about the energy that's required to remove the most loosely bound electron. We're going to remove one of the valence electrons. So if we look at table S in your reference packet, we'll find out that as we go across a period, the trend tends to increase. The reason why is there is a stronger pull by the nucleus on the electron, so it makes it more difficult to remove an electron as we go across the row. So the less nuclear charge, here we've got a much bigger distance, then here with the chlorine there's a much smaller distance. Now as we go down a group, the trend tends to decrease. The reason why is the larger atomic radius means less nuclear pull on the outer electrons. And remember, as we go down our groups, every time we go to another period, we add another energy level. So it gets bigger and bigger and bigger as we go down. So using table S to determine trends. To figure out what we need to do is we need to pick an element in a particular group and look at the values of the elements. And then we're going to go down a group and find out what the trend in the ionization energy is. So we're going to look at sodium, potassium, and rubidium. Any group will work. And if we were then to look at these here, on our reference table S, we would notice that sodium has an ionization energy of 496. Underneath there's potassium at 419, and underneath potassium is rubidium with 403. Therefore, the trend is decreasing. So what is the trend in ionization energy going down a group? Well, the trend going down the group is decreasing. And why does this occur? It's because the radius gets larger. Larger radius, less nuclear pull. So electronegativity is the measure of the attraction for electrons. So if we look at table S in our reference packet, fluorine is the most electronegative element. It has electronegativity value of 4. The closer an atom is to fluorine, the higher the electronegativity. The scale will range from 0 to 4. So as we go across a period, the trend will increase. This is because there is a stronger nuclear pull to attract electrons. Now, as we go down a group, the trend will decrease. The reason why is there's a larger atomic radius, and this means there is less nuclear pull on the outer electrons. So we'll use table S, and we'll pick a row or pick a column, it doesn't matter, and we'll look at the period first, and we'll see what happens to the atomic radius. So we'll look at sodium and chlorine, and if we look here, my trend, if I go from sodium, is 0.9 to chlorine, which is 3.2, therefore it does increase as we go across our row. So what is the trend in electronegativity as we go across a period? It will increase. And why does this happen? Is because we have a stronger pull on the electrons from the nucleus. So here's a summary of what the trends are. So to check your understanding, what is the trend in ionization energy going down a group? As we go down a group, it will decrease. And why does this trend decrease as we go down a group? It's because the larger nucleus or the larger radius will have less pull.